in terms of, for example, I'm going to touch base with your experience about this passive house project here in Red Deer, which is Scott's Subaru. I was talking with the owner a few weeks ago, and later on I was interviewing also the contractor. And I was always pretty curious about the mechanical component, how that worked in the process, right? So maybe you can just give me a little bit more of understanding how that process went in order to kind of just make that that building works in terms of mechanical components or electrical components as well. So maybe you can just give me a little bit of insight about that.
Sure. So we were the mechanical and electrical consultants for the Scott Subaru project here in Red Deer, Alberta, which is, as far as I know, it's the only Passive House certified car dealership. And so we were tasked with designing the mechanical and electrical systems for that. Now, we weren't the consultants for the Passive House, and so there was another consultant that was actually handling the certification process, but he gave us guidelines. So he outlined maximum working parameters. So he would dictate things like, well, what is the maximum wattage we can use for lights? What is the minimum efficiency that we need for our mechanical equipment, and minimum certifications, and minimum recovery on things like ventilation, air. And then with those, armed with those minimum standards, we had to go out and find compliant mechanical equipment. Now, given that even though the local equipment that we were accustomed to, I would still consider them very high quality, they didn't meet the standard that was dictated by the consultant that was handling the Passive House certification. And so we had to go very far. We had to use the most specialty equipment, and we had to employ things that were used in other jurisdictions, knowledge about mechanical equipment from other jurisdictions, and apply them to this area. Unfortunately, again, being that the equipment was not originally designed for the extremes of our temperature, we found though that a lot of the equipment there, it had to be adapted to our local context, and it didn't adapt as well as what you might hope. So equipment that would work just fine at, say, minus 20 doesn't work at all at minus 30 or minus 40, but minus 30 or minus 40 degrees centigrade is a common thing that we would see in a wintertime in this local area. So it was simply not an option for us to use a piece of equipment that only operated down to minus 20. So what it forced was unusual things like where we had to double up on the mechanical system just to account for the short periods where we knew that the primary mechanical system wouldn't function because it was either too cold outside. It made the process difficult, but the other thing is that in that particular context, we found that the majority of the knowledge that was available to us with regards to Passive House, it didn't deal with the extremes that we were experiencing. And so there was no common knowledge for how to operate a super high efficiency mechanical system in a minus 40 context. That, or where we have the extremes where even in their summertime months, we still have very high cooling demand. We have very high heat gains. So the building still suffers from the same environmental conditions as any other building. The extreme envelope and the high quality of the components that were in that certainly helped, but not to the extent that it could eliminate any of these other things. And so we still needed a mechanical system. We still needed mechanical cooling. We still needed mechanical heating, and trying to find equipment that was simultaneously very high efficiency and meeting the minimum standard of the Passive House and also appropriate for our local context was extremely difficult.
So what you're saying is that even though you were trying to kind of just go through it and trying to kind of maybe double size the mechanical requirements or whatever in order that piece of equipment could work on this specific location. So you're talking that you made it work with local components, like something that was actually manufactured in the country, or how that works?
Well, we did acknowledge that although we did regularly have minus 30 and minus 40 days, like days in which we knew that the primary mechanical system wasn't going to function, those days are always limited. And so even in the coldest of winters, we might experience only maybe a week or 2 weeks where those, and a lot of times over the course of a 24-hour period, it would only be that cold at nighttime, for example, rather than throughout a 24-hour period. And so although the building is subjected to those extremes, they're not always going to be around. And so there was a certain acknowledgement and there were certain allowances by the passive house consultant that just simply acknowledged that there was going to be times when we weren't able to use the highest of efficient
Correct.
mechanical piece of equipment. And so our solution to these issues was simply doubling up. That's all. And so it was the addition of mechanical equipment, traditional mechanical equipment that we knew would function in our local context.
Correct. Because something that I want to understand as well is, like, for example, for this specific certification, right? There is like this myth that, okay, well, if you want to kind of make passive house work in extreme weather conditions, you have to kind of just bring all the mechanical equipment from Europe, right? So is that true, or you basically are able, understanding that maybe you have to kind of take an average or something out of the extreme climate, you can just make it work with local components then?
Yeah, so a lot of the building components did come from Europe, which I believe that you talked about in your previous podcast.
Yep.
And so the mechanical components were somewhat local. Like they were common. They're commonly used in the UK. They're commonly used in the more temperate parts of the United States. And so this equipment does exist. It's just that the local knowledge, the people that the vendors that rep these pieces of equipment, they simply don't have a lot of local representation, because in anything other than a passive house context would never be sold, because again, they're simply not appropriate for this climate, right? I mean, if it doesn't work past minus 30 or minus 20, then it doesn't serve any purpose here. And so there's no reason for a vendor to know that information. Like there's no technical knowledge of how these things would function in these extreme conditions outside of their own data sheets.
Correct. Yeah, and the other characteristics of this equipment, right, is also the air tightness of the actual equipment as well, right? And they have to kind of just pass certain leakage air through the actual system, not only the envelope, but the actual mechanical system, right? So, and I was thinking, well, yeah, I don't know how that's even work on these type of components, right? So
yeah, one of the examples that we went through, which was interesting on the Scott Subaru, was the issue of plumbing vents. And so plumbing vents are simply waste pipes that stick through the roof that relieve pressure or relieve vacuum and assist with the proper drainage. So it's part of a properly designed drain waste vent system. But being that this is a penetration through the roof, there was a certain amount of leakage. There was a certain amount of envelope losses through plumbing vents. And it's not that Passive House strictly forbade them, but they had very strict rules and interpretations, and in most cases, especially in residential scenarios, alternatives were sought. That's all. But as much as there was available for alternatives, there was as much opposition to those alternatives as there was products available. And so every time that we would come up with a solution to avoid actually putting a plumbing vent through the roof, we had to contend with a plumbing inspector who understandably only understands plumbing vents, because this is the way that plumbing is done in our local context.
Right.
But we tried. We certainly tried to find products, and there was solutions. But again, certain things like CSA certifications for use, like they were simply not permitted in the plumbing code. And so there were certain compromises that had to be done. And at the end of the day, we ended up with traditional waste sacks and traditional waste vents through the roof, just like you would expect it to do. But we just simply paid it. We did the best that we could. So it was insulated, it was sealed, and we did the very best with what we were given.
Right. And yeah, well, and I understand, like not only passive house, but other type of certification or other type of projects, they have difficulties on their own by whatever nature of needs of the client, right? So I want to kind of just double check another myth that I have, and I want to kind of know your point of view about if the heat pumps actually don't work in Alberta. What can you say about that?
Yeah, and so heat pumps, which actually form the majority of the primary mechanical system on the Scott Subaru, these were the limiting factor on the heat pumps was their inability to work past roughly about -20. And so it's not that they don't work; they certainly work. It's just that they only work during certain environmental conditions, and unfortunately, our local environmental conditions exceed that. Now, the other thing about heat pumps is that they run a compressor. So if anybody has to pay their power bills in the middle of summer, they know that the power bills are expensive because air conditioners run, and air conditioners use a form of heat pump which runs a compressor, and it's very taxing on electricity. Normally, when we burn natural gas in the wintertime in order to keep our houses warm, the only electrical load is the fan to move the air through some form of a heat exchanger. Now, I mean, I'm discounting things like boilers and boiler pumps and things like that, but in a traditional forced air scenario, the only electrical load in the wintertime is to move the air around. But in a heat pump scenario, if you're using a heat pump as your primary source of heat, you not only need to move the air, but you also have to run the compressor for the heat pump. And so it's almost like running an air conditioner in the middle of wintertime. And so it's nice, especially here in central Alberta, that we get some reprieve from heavy electrical bills in the wintertime. But in the event that a homeowner were to use a heat pump instead, they would basically be paying air conditioning rates all year round.
Correct. And then now, in order to kind of just have another sense of this conversation about you were talking back and forth with the subtrades, like the actual mechanical electrical subtrades in the process, right? How was your experience in that regard?
Yeah, and so when we deal with subtrades, like when we communicate directly with the subtrades, it's usually just to figure out what is available and what is reasonable to install. There's a lot of products available to us, and admittedly in our mechanical and electrical consulting field, it's simply finding and deploying specific pieces of equipment. And so it means that it's very vendor driven. So when we deal with mechanical equipment especially, it's finding the right piece of equipment out of a proverbial catalog or website or whatever it is. But just because that particular piece of equipment exists, it doesn't necessarily mean that it's either available or it's easy to use, or if it's economical for what it does. In a lot of cases, we need to find a piece of equipment that doesn't just meet the technical requirements of the project, but is also readily available and the subtrades enjoy using it. And so when we deal with the subtrades directly, it's a combination of communicating with the subtrades to make sure that they're capable and willing of installing what we're picking out, but it's also to figure out what they prefer using from a vendor point of view, the technical information from their preferred vendors, and that sort of thing.
How do you like it so far? Thank you for being with us. If you want to know about the following part, just keep in touch and follow us for the next part of this episode. And please don't forget to leave me a review on whichever platform that you're using to listen to this podcast. Either good or bad. Remember, Mexicans have thicker skin. You won't hurt my feelings, that's for sure. And better yet, if it has some good criticism so I can learn from it and improve it, that will be even greater. I understand this hasn't been perfect, but it can be better every time. I recognize your time is valuable. I would like you to enjoy this moment with me as well. Also, if you like what you get from this audio, I will recommend you to be the first to share this info with your friends, so maybe they can get something valuable from it as well. Thanks for listening, and let's meet again soon.